factor A, which is about the first order differential equation. What do we still remember from last lecture? So if we have a system of first order linear differential equation, how can we write it? As what? Matrix form. And this matrix form is of which form? So how do we write it usually? X prime equal A at out. And if this after we get this function. How did we discuss? We have a system of differential equations. What's our aim? To check what we mean by solution, right? Then, do we care about one solution only? Or do we care about all possible solutions? From these possible solutions, if I'm telling you that e power t 0 as a vector is a solution, and 2e power t times that 2e power t 0 is also a solution, for us it doesn't make sense. From one solution for a homogeneous system, I can get every scalar multiple of it is again a solution. Which solutions do we care about? We need to cover all linearly independent solutions. Now, all of these linearly independent solutions, what do we call them? We call them fundamental. And how do we determine if it's fundamental satellite? We need to find the RAS. If it's not equal to 0, then independent, their number is the same as the number of equations and number of elements, then it will be the fundamental set. And at the end, how do we write our solution as linear combination of these vectors? Okay. We also prove that we also prove the existence and uniqueness of a solution vector. How do we check? We go for the matrix A, we go for the column matrix F, and we check all the entries. If they are continuous, what can we deduce this? That it is unique, it exists, and unique solution. Okay. Secures. This one? Okay. Okay, what's our aim for today? We will not be always provided with the solution. Our aim is to find the solution. Now, what we will learn in this course is not how to solve every linear system. We are concerned. Let's look at our type. First order linear. Okay, so first order and we will start with, we will cover more than one case. The first case, we will cover the step 3 roots. Until this one, we'll cover it today. So our objective is to apply which method? Eigenvalues and eigenvectors to solve first order linear systems of bodies. Let's start at the start. We'll start with the homogeneous part. We are given x prime equal ax. A is n by n matrix of constants. So again, the restriction that we will deal with in section 8.1, A, we were able to put t and n, sine t, cosine t. This method is applicable for having A as constants. Okay? The general solution of it is x equal k e lambda t. K is a column vector that contains n components and e lambda t. What do you think? What will be our lambda? What's our lambda? So please remember this when we have the differential equation that is linear with constant coefficient. How do we start? Y equal either mx, right? Substitute and get an initial equation or arithmetic equation or whatever, or auxiliary equation. Here, instead of starting as ax or the x is equal to emx, I cannot write emx alone because it's a volume and actually b1 should be a vector, right? And plus x isn't a vector. Okay. So I will write x equal K E lambda T. Substitute what will we get as X prime. It means that lambda E lambda T equal AK E lambda T. And then what will we get with? K lambda equal to AK, this is K. Okay, and then we will get this one. This one, does it remain us of something? We need the non-trivial solution, right? Are you interested in this trivial solution? Of course, the trivial solution that exists here. I don't care about the trivial solution. We care about the non-trivial solution. So what do we need the determinant to be equal to 0? And this one, it gives us what? Eigenvalues. Okay? Is it the eigenvalues? Okay, then how do we find K using what? K will be the eigenvector. We will find A minus lambda I. Now, if you look at this case, at this one, we are not doing anything regarding the differential equation. What are we doing exactly? Linear algebra, eigenvalues and eigenvectors. So when we have such a question, let's look at this one. This one is two equations, two unknowns. First, is it homogeneous? Okay, what's A? Constant options. Okay, we will go and find what? Eigenvalues. Then after the eigenvalues, what do we need to find? Eigenvectors, and then just put the answer. So did we do derivative and derivative or any other things? Okay. Now the idea is that the eigenvalues in linear algebra, what did I tell you about it? Are they always distinct? First, are they always real? They can be complex, and I told you in the differential equation we'll discuss it. So we need to differentiate the cases as real and complex. And in the realness, we have the distinct, and what do we have? Repeated. So also we will consider it as two cases. So we have here basically three cases: the distinct, the repeated, and the complex. We'll start with the distinct. We'll solve two examples. If we have enough time, we'll do also the repeated eigenvalues. Okay, miss? So the main thing, first we write. So the steps, first, how do we write the system of differential equation? X prime equal A X. Find eigenvalues of A, then check the eigenvalues, which category of these ones it belongs to, the gray, the green, or the pink. At this moment, I will not explain the green and the pink. We will explain only gray. Okay, miss, which is distinct, real groups. Who was sick last year? Last week. Who was sick from you last week? Who was sick?
14 days I was sick.
So you spread the virus.
Did not come. If you remember, I did not come that 1 week.
I did not come. Maybe you said that before. There are virus today.
Yes, it did.
But I don't have fever. This is why I'm coming to the university. I don't have fever. I just have.
Did you contact with children? Did you have contact with children?
I have.
Contact with children. So don't that this virus came from the schools. If you have children,
But is there fever with them?
uh,
Is it coming with fever?
it's different actually.
Okay. So let's start with the first one. again, as a peer, we are revising linear algebra. So what do we need to find? Eigenvalues and eigenvectors. I shared with you a video about finding eigenvalues and eigenvectors. Of course, my students don't need to go for it because it's me. I explained it before in linear algebra. For the others, if you took it before, please go through it. What do you mean by distinct eigenvalues? If A is 2 by 2 matrix, it means that I should get 2 distinct eigenvalues and one real. We are starting with the real part. So for example, if A is 5 by 5 matrix and I have the eigenvalue 1, 2, 5, 7, and 9, it's accepted, it's in this one. Okay, miss? So first of all, we will identify these eigenvalues. Then each of these eigenvalues, we will find its corresponding eigenvector. Okay, miss? So solution, it will be the first eigenvector multiplied by d lambda 1t. Didn't we start it this way? Didn't we start at k e lambda t? Oh. The second one will be the second eigenvector e lambda 2t until we reach the end. How many did we get? And are they independent? Of course, independent because different e power different numbers. So if I have e power t and e power 5t, of course, independent. Okay, because they are independent, how do we write the solution, the final answer? Linear combination of. Okay, miss? Now, how do we know that this is our only solution? This is the general solution, and I cannot find more. Our solution will be independent. These are the only solutions, independent solutions that we have. Start with the 2 by 3 matrix, solve it in details, system of 2 equations, 2 ODEs with 2 elements. Then we will do a third one with 3 equations and 3 elements. Okay. Did we write? Did we finish writing our notes? So the fundamental set of solutions as K1 E lambda 1t, K2 E lambda 2t, then we reach K and E lambda and t, and the linear combination of it will be the general solution. Let's look at this one. What we will do now is just I need to write the system and we will solve it in detail. Let's go here. The first step that I need from you to do is to write this one in matrix form. So it's written as system. We can have the question either as system or already in matrix form. This one is as system. So So first step, we need to write the matrix form. How many equations do we have?
Two.
Two equations. What's A?
2, 3, 2, 1.
2, 3, 2, 1. This one that is here. Can we apply the method of eigenvalues? Yes, because this one is homogeneous plus these ones are constants, right? Okay. So the first step is we need to find the eigenvalues of A, then check which category it belongs to. If it's real or complex, and if it's real, whether it's repetitive or it's always this one we want to work with eigenvalues and eigenvectors. The first step is to find A minus lambda I. Which I we need here? I. We will copy again the matrix 2, 2, 3, 1. And there you can remember what do we put for the A diagonal? Minus lambda. Okay. We write this matrix, we'll put it in a box because this one we will use it for eigenvalues and eigenvectors. Okay, what I need from you to do, because already almost to linear algebra, we need to find the eigenvalues. The eigenvalues go for what, Shamus? Determinant of this one equal 0. Okay, so remind me what's the determinant? How do we find determinant of two-way two matrix? So now we divide our work into two parts. First part, we will find the eigenvalues. The eigenvalues always how do we find A minus lambda I? I will write 2 here, but in the exam, if it's 4 by 4, I put I4 and so on. Equal. This one we will highlight it. Okay, and then we will start. So A minus lambda I2, 2 minus lambda, 3, 2, 1 minus lambda, and B. Miss, if you are thinking with other instructors, instead of A minus lambda I, we write lambda I minus A, which is this thing, okay? It doesn't affect the answer. Usually, sometimes I use lambda I minus A instead of A minus lambda I, but most of them would be the same lambda, same eigenvectors. It is the main diagonal minus second diagonal, right? Now we need to simplify it by expanding, okay? 2 times 1 minus 2 times lambda minus lambda times 1 plus lambda square, and here minus this equal to 0. Now write it as a polynomial. This one, it will be the characteristic equation, right? It has lambda square, lambda, and constant quantity. So all we get here, lambda square minus 3 lambda
minus 1.
minus 4 equal to 0. This one we will highlight it. And this is our characteristic equation. From it, we will find the eigenvalues. Now, regarding solving it, you have the right to solve it either using the calculator or by factorizing as you prefer. or using it in any way that you feel comfortable. Okay, so find the roots for it. Those who finish writing, please find the roots.
I'm the one who's on one, 4, and minus 1.
1.
So we will get lambda 4 and 1 minus 1, right? Which is lambda equal 4 and lambda equal -1, right? What's A? What's the size of A? A is 2 by 2 meters. How many eigenvalues did we get? 2. This is the 3 eigenvalues. We have here 2 distinct, 2, and here the size is 2. So this one is which case, miss? Has the distinct real eigenvalue. So we identify the case. Now we'll move and find what the eigenvectors.
You need to say this derivative value.
Hmm?
You need to say the answer.
I'm putting it to explain.
Mhm.
Now, in the exam, you have just to say distinct real eigenvalues. So after you finish writing from the board, you need to find the eigenvectors or the independent eigenvectors corresponding to each of these numbers. So now we can give them, rename them lambda 1 and lambda 2. Any questions? Did you finish writing from the board? Now, what do we need with eigen? For eigenvectors, how do we do it? A minus lambda I. In our case, we would put eigen. And here we put, and this one we put it in a box because always when we are finding eigenvector, we will use this one. Okay, miss? So what do we need to solve now? We need to solve this minus lambda, 3, 2, 1 minus lambda, 0. And we will start with what? Lambda 1 equal. It means that substitute here lambda equals. We substituted lambda equals 4. What will we get? 2 minus 4, -2, 1 minus 4, -3, and here what we put? But these distance from for finding eigenvectors, you cannot solve it using the calculator because we will get infinite solution.
Yes.
Remember this, when we are finding eigenvectors, at least we will get how many rows of zeros? 1. In the case of distinct eigenvalues, we should get only 1. Okay? Repeated, we may get more with that one. And we will explain the two cases. Okay, miss? How would you like to solve it? So here you can transform it to RDR, or you can look at these ones, miss.
Yes.
What is they dependent on each other?
Yes, yeah.
So we can remove the last one. They are multiple of each other, right?
Yes.
So I can remove the last one and put instead of it one.
Zero.
Or if you want, just add R1, R2, gives R2, and again, we will get seeds. But when you have dependent rows, let's say I have the first row the same as the second, the same as the third. I will keep the first and second and third and put zeros because they are dependent, even if they are multiple of each other. Okay? Okay, so what will be the new matrix now? Please write this one down. This one we are doing it in details because the next one you will do that. You received the animal, I will start at line 48 and on team size. What will be the new matrix now?
-2.
Minus 2, 3, 0, 0, 0. Is it row echelon form now? Minus 2, 3. This one is 3 parameter. Instead of calling it x, y, we will call it k1, k2. Okay, so the parameters, in order just like not to mix with the x and y that is here, it's better not to call them x and y.
Yeah.
We will call them, this one is k1 and this one is k. Okay, which one is the three parameter? So k2 is t and t belongs to our source. Okay, miss, what will we get now? Substitute negative k1 plus 3. Instead of k to e, k2, t equal to 0. So k1 is equal to
Minus.
3. Minus over minus. So it will be 3 over 2. Okay. K1, K2 is equal 3 over 2 t and t. What do we think? We can summon that. The last part, lambda 1, what happens to lambda 1 is 4. What's the independent eigenvector for that? And you will put it in a box. Okay, miss? Is it clear? When we finish the first part by just after we wrote the matrix form, you are feeling now that as if you are in a linear algebra class, right?
Yes.
We don't have to, are just explaining linear algebra. Again, the solving linear system, this is not the only way to solve it using eigenvalues and eigenvectors. We have other methods. Laplace transform is also in our syllabus. As our syllabus doesn't cover Laplace transform for systems.
Solving it by Laplace is easy than this.
Solving it by Laplace, you are required to apply the Laplace. You need the Laplace forms, and then you will apply the inverse Laplace. So you will need linear algebra and because you have a system, you will apply Laplace both sides. Then you need to apply Cramer's rule after that, or substitution, or this method, and then inverse Laplace.
So
This one is easier, but for which case? For if it's first order, we are applying this method, and if it's linear with constant coefficient. Laplace, it will be helpful. Let's say this one is constant coefficients. So eigenvalues and eigenvectors work. But suppose here you have something multiplied by it, or you have plus t, or you have this one multiplied by e power something. So I cannot apply this method. I need to apply that plus. But of course, plus it will be longer. Do we have any questions regarding this one? Now we will do. Are we done with? What do we have now? Oh, so we need to go for lambda 2. Lambda 2, it was equal negative 1. We will substitute a minus lambda I. 2 minus minus 1, 3. 1 minus minus 1. How do we know when we are doing eigenvectors that we have a mistake? If we do not get any zeros. Okay? Now look at these two rows. Are they multiple of each other? Immediately I can use the last one. But if you want to deal with it as from linear algebra, I can say minus 2 over 3 R1 plus R2 give R2. So we will get here 3, 3, B with 0, and B. Again, we will call this one K1, this one K. Which one is the three parameter?
Yes.
So we will say these K. R star. What do you mean by R star? It's not 0. Okay. So 3K1 plus 3 T equals 0. It means that K1 equals minus. So what will we get K1 equal as? So we will get now lambda 2 negative 1, it goes to negative 1, 1, and we will put it in a box. Okay. Now, let's try the ones that they are highlighted. Lambda 1 equals 4. It goes to 3 over 2, 1. And lambda 2 equals negative 1. It goes to negative 1. How many independent solutions should we get, Miss? This one, it will give us x1, and this one, it will give us x2. Remember, this one, e power 4t here we put, and here we will put e power negative t. From where? These things, okay? And what do we put here, Miss? The eigenvector. What's the eigenvector here? What's the eigenvector here? Negative 1, 1. Okay, Miss? Now, how can also be write it in another way? We can put the e power 14 inside, or we can keep it outside as we wish. Are we done? Then what do we need to write? General solution. C1, x1, E2, and this will be our final task. Do we find the values for C1 and C2? Okay, but suppose that it's an initial value problem. We will find C1 and C2, okay? We'll solve later on initial value problem. At this time, I don't care about initial value problems. Lu'an, is it clear?
Yes.
Okay. Now, to make sure that everything is okay, I will guide you in each step, but we need to work it out. The next system that we will deal with is three equations with three unknowns. So how many independent solutions should we expect? Can we move to the next one? Can we move to this one? Please write the system, write it as x prime. But A, it should be 3 by 3 matrix. Our elements
Minus 1.
minus 4, 1, 1, 1.
Minus 3.
Okay, the last one.
0, 1.
Oh, what's our A? This one is our matrix A, right? So this one is our matrix A. Right, A minus sum dot. We need to write now A minus sum dot. Okay, what will we get? We will copy it again. And we will subtract lambda shot from the main value. Now the eigenvalue.
What you see?
I'm waiting for you to interesting information. During this time, I will take that. Yes. What will be the determinant? Minus 4 minus lambda, 5 lambda minus 3 lambda minus 1. So plus minus plus minus 1 into minus 3 minus lambda plus 1 into 1 equal to 0. Right, miss? Then we need to expand. The first step, did all of us make it this?
Dora, isn't it plus 1? So it's minus 1.
Where is this? We covered this one, minus 1. You covered this one. Original matrix was minus 1. Ah, okay, I copied it. Yes, okay. So this one is. No, it's minus 1. Minus 1. So in this way, so this one will be x plus 1. It's not here. Abdelaziz here, Shams here, Abdurrahman here, Muayyad is not here. Lu'ay here, Sultan is here. Abdullah al-Mansuri is not here. Darshad is here. Ismail is here. Abu Said here. Amr is not here. Johnny is here. Ali is here. Ahmad is not here. Yes. We will evaluate this one first. 5 times negative 3, negative 15 plus 1, negative 14. Here we have plus lambda squared minus 5 lambda minus 3 lambda is negative 8. Okay? Did all that get it in this way, miss? Divide that is inside. Did we get it in this way? Okay. What will we get now? Let's write it. Negative 4, negative lambda. Lambda squared minus 8 lambda minus 14. The second one is plus minus 3 plus 1 minus 2 plus 2 plus lambda we would get. And oh no, I have. Okay, so this one it will be plus 3 plus lambda. So we'll write here plus 3 plus lambda, and already we have here plus 1 equal to 0. Right, miss? Plus 3 plus lambda plus 1.
Minus 5 lambda plus 3 lambda. So minus 3 lambda.
Minus 5 lambda minus 3 plus this one. Okay. Minus 2. Okay, we will put here we'll put minus 3. The other ones must we copied them correctly. Okay, expand again. What will we get? Minus 4 lambda squared plus 8 lambda plus 4 times 14, 56 minus lambda cube plus 2 lambda squared plus 14 lambda. This is the first one. Is it correct? Plus 4 lambda equal to 0. What will we get now? Negative lambda cube. Lambda squared. We have negative 4 plus 2, so negative 2 lambda squared. For lambda, we have 8, 14. It means that we have 22 and we have 1, so 22 lambda. For the constant, we have 56 and 4, which is Please check this one.
There's
We have 23.
a number now.
8 and 14 and 1.
That's 12.
8 plus 14, 22, so 23. Okay. This one is our characteristic equation. Did all of us get this one, or there is a typo this? We got this. Okay. What are the eigenvalues that we got this?
5 minus 3 minus.
Okay. So lambda 5 that
3.
minus. Okay. All of us should be getting these ones. How many did we get, Miss?
8.
3. 3. What do we have to mention? Real. Okay. And what is 3 by 3? So which case are we in now? We are still in the first case, right? So we will call them now lambda 1, lambda 2, and lambda 3. We will write now lambda 1 equal to 5, lambda 2 equal negative 3, and lambda 3 equal negative 4. So what do we need now to find them? Eigenvectors. How do we find the eigenvectors? We will copy the matrix again. Negative 4, negative lambda, 1, 1. Please make sure that I will copy it correctly, Miss.
Yes.
Now start with lambda 1 equal to 5. What will we get the matrix? Minus 4, minus 5, minus 9, 1, 1, 1, 0. Negative 1, 0, 1, negative 3, negative 5, and
Now look at this.
now, Miss, it's better to avoid having fractions. We can put the one up. Interchange these two ones, it's easier. So the first step, try to interchange R1, R2, get the one up. It will be easier to deal with. So we will get 1, 0, negative 1, negative 9, 1, 1, 0, 1, negative 8. And here what can we say? 9R1 plus R2 get R2. What will we get from this? Last two rows, are they identical? Can we move to the last one? How do we call them X, Y, B? Continuous multiplication. Okay, so how do we continue? K3 belongs to R. What will we get now? K1 minus D equals 0 and K2 minus 18 equal to 0. How do we solve that? Start from the second, right? So K1 will get an D and K2 and A. We can take T in common, 1, 8, 1. So lambda 1 equals 5, it goes to 1, 8, 1. We put it in a box. We expect to have 2 more from the second 2 lambdas. Okay, miss? Is it clear? Now, what I want you to do is this part, find the eigenvector for lambda 2 and this part for lambda 3. And I'll take the answers from you. Okay, miss? So from this one, we can deduce this one. What does it mean? The first solution is of which form? E power 5 E. And what do we have here? This would be our first solution, right? So still we should have 2 solutions. The right hand side will give me the second solution, and the left hand side will give me the third solution. of the second one, what did we get, miss? What did we get also for the second one? Okay, so let's go briefly for the case of that we when we get 3 substituting the first step. Are you okay with it? Is this what we get when we substituted, miss? So what did we get when we substituted?
I think the second one, the one you get R1 plus R2.
I did not do this step. Okay. Okay. The shot, what did we get?
One eight minus 1 0 9 0 0 0.
Oh, you switch. Yeah, it's okay. It's okay. We'll get similar answers. No worry. Okay. Smile, what did we get? Okay. Okay, perfect. So then the last row will get it as 0. K3 is equal T belongs to R star. We substituted and we get our second solution. Right, miss? What's left? What do we need to find? Our third solution. Those who did the third one, what did we get, miss? Okay, let me check. So the third one, it's for lambda equal, lambda 3 equals what, miss?
-4.
-4. So -4. Substitute, what will we get, miss?
-4 minus 4.
-4, -4, 0, right? 1, 1, 1, 5. -1, 0, 1, -3, -4, and 1, right? Now these two rows are the same. And also, what can we do with R1? We can change it with R2. Do you know why? Why do we need to interchange? So first we will do negative R1 plus R3. We will get this one. What's our parameter? K3 equal to 1. Substitute, what will be that, miss? K1 plus 9 K2 minus T equals 0 and K2 plus T equal to 0. So if we're facing problems in eigenvalues and eigenvectors, please, we need to practice and go back again to the material and the recording in linear algebra. What will we get now, miss? So we will get K2 equal negative T, K1 minus 9 minus T equals 0. Is that K1 equal 10? What will be lambda 3 equal negative 4? K1 and K2. Negative 1 and this one, 1. And x3 will be equal to 1 E minus 40. Here we have 10, negative 1, 1. We will put it in a box. Miss, we got x1, we got x2, we got x3. What's the lambda? We need to write the general solution. How do we write the general solution? X equal T1 x1 plus T2 x2 plus T3 x, and we need to write again x1, x2, and x3. Should I go to the previous slide to write it, or you're okay? Because already you started with it. Again, this question is the same as the question in linear algebra. We have to pay attention. Be careful when we are finding the characteristic equation, because if we did not find it correctly, everything would be wrong. So here we have to do practice. And already in linear algebra, we have also in differential equations, we have, if you look at the end of this one, this one was shared on Blackboard. The last 2 slides, it contains lots of practice examples. And of course, you can like that. So let's go back again. We have x prime equal ax. A contains only constants. F is 0 because we are interested just in the homogeneous part. The first step, what do we need to find? The matrix A. Then find the eigenvalues. To find the eigenvalues, we go for A minus lambda I. How do we determine A minus lambda I? We write A again, and we lay down and what to put beside it, negative plus. Then to find the eigenvalues, we go for the determinant of A minus lambda I equals 0. If it's 2 by 2 matrix, AB minus BC equal to 0, we will write, and if it's 3 by 3 plus minus plus. Usually the comment is 2 by 2 and 3 by 3, but of course in the exam we have to expect the 3 by 3. Okay, now the 4 by 4, if we want to bring it, it should be like the matrix sentence, it's easy to deal. Then after finding the eigenvalues, we need to determine which among these cases is it real or complex. Okay, if it's real, is it distinct? When we say distinctness, it means that if it's 5 by 5, I should get 5 distinct and not 4 distinct. So I will count the distinct. Are they the same as the size of the matrix related to the size? How do I continue? If distinct, each eigenvalue I will find its eigenvector. So I will find a solution x1, then x2 till we reach x1, and finally we write the general solution as x equals c1 k1 e lambda 1 t till we reach the last one. Is it clear?
Yes.
Now, what's next?
Okay.
Okay, now for the repeated eigenvalues, we have also 2 cases. We have case 1 and case 2. Do you still remember that in the repeated eigenvalues, the matrix can still be diagonalizable, right? Right, miss? If one of the eigenvalues has how many eigenvectors, independent eigenvectors, more. So we will take the 2 cases. If we have an eigenvalue with multiplicity 2, but it has also 2 independent eigenvectors, we don't have a problem in it. We will get solution, the first eigenvector multiplied by e lambda 1 t, and the second eigenvector multiplied by e lambda 1 t. This one you don't have issue. Where would we take the issue? If we have multiplicity 2, but how many independent eigenvector we have? 1. So this one, it will be a new method to solve it. Not a new method. The first part of it is the same, but we need extra work for it. But this one, it will be almost the same. And you can start with this part. Try to practice on the eigenvalues and eigenvectors of this exercise. That is. Do we have questions, Miss? Okay, Miss. Have a nice weekend, and I will see you hopefully next Tuesday. We need 2 more lectures for chapter 8. Okay, Miss? I will share the annotations with you, and if you have free time, you can go to the ground floor, the auditorium for the event, and try to connect with people there.
Thank you.
Welcome, Ms. Stephen. You too. Miss.